Hello, I'm Carl Dietrich with SDRS Wireless. I also work as a research faculty member at Virginia Tech. We'll be talking now about one of the HLSI, or hands-on learning for radio frequency spectrum innovation simulations developed by Virginia Tech to help people learn fundamental concepts in wireless communications. The simulation we'll look at right now uses free space path loss in a user configurable geometry of 2 transmitters and 1 receiver, and it also shows these signals from the 2 transmitters, which can operate on different frequencies and do operate with different bandwidths. On the left, we see a canvas or a grid with the transmitter and receiver locations indicated by markers and the transmission paths indicated by dashed lines. On the right side, we see a power spectral density plot that shows the relative signal strength as a function of frequency, with frequency on the horizontal axis and power spectral density on the vertical axis in a relative scale. In addition, we have some text at the upper left that indicates things like the distance from the receiver to each of the transmitters. We'll call one of the transmitters a user and consider that to be the desired transmitter. And then there's another transmitter that we'll call an interferer, and that distance is also listed at the upper left of the screen. And for each of those transmitters, the path loss, calculated using the Frisch transmission equation for free space path loss, between that transmitter and the receiver is also shown in dB. Below that is a display of the signal to interference plus noise ratio, or SINR, measured in dB. And calculated based on that, and assuming that the interference can be approximated as noise, we have the information capacity, in this case in kilobits per second, as calculated using the Shannon-Hartley equation for information capacity of an AWGN channel. The only control, other than the ability to click and drag receiver and transmitter locations, controls the frequency of the user or desired transmitter signal. You can see that by moving the transmitters or the receiver, we can change the relative strength of the 2 signals as seen at the receiver. So students can explore different strategies for reducing interference and increasing the achievable data rate as indicated by the information capacity of the channel. Variables at the student's disposal include the geometry, as controlled by clicking and dragging radios or markers that represent the radios on the grid at the left of the display. And also, students have the option to change the frequency of the desired transmitter and to see what effect that has. And in this simulation, the receiver will follow the desired transmitter to any frequency that the desired transmitter is tuned to. I hope that this tour of the simulation has been useful to you, and that the simulation and the other ones in the series will also be helpful to you, and I look forward to seeing you in another video soon.